Hello, Chemistry 10 and Chemistry 10H students. This is Mrs. Altman, and this is the first part of the Chapter 11 video series where we will be discussing the wave mechanical model of the atom. So I will be reviewing some of the notes as well as doing some new examples that are not in your notes. So we're going to go through some of the rules. The actual applications are much simpler than these rules would lead for you to believe. The first postulate of the wave mechanical model of the atom is that atoms have a series of energy levels, sort of like layers of an onion. They're called principal energy levels. N is equal to 1 is the first layer closest to the nucleus. Then N is equal to 2 is the next layer further away. N is equal to 3 is further away than 1 or 2. As N increases, the energy also increases. And then within each energy level, we have one or more types of orbitals. What that means is just different ways that the electrons are moving around the nucleus, so different shapes. And then within each shell, whatever the number is, that's how many subshells there are. So N is equal to 1 has 1 subshell, N is equal to 2 has 2, N is equal to 3 has 3, and so on and so forth. And then I'm going to actually explain these last portions by sort of writing this out. So what this really means is that 1s is the only type of orbital allowed in N is equal to 1. So the 1 is for N and S is for the shape. So there's SP, D, and F. It's always going to go in that order. For N is equal to 2, we've got 2s, 2p. Those are available. Then there's 3s, 3p, and 3d. And then we have 4s, 4p, 4d, and 4f. So past S, P, D, F, and if you were wondering where those letters come from, they actually come from German words for the shape of which these look like, and we'll talk more about what those shapes look like in a moment. These are in short, what is allowed. For higher numbers like 5, 6 or so, you would have other possibilities for the shapes, but we're only going to be discussing S, P, D, and F. Right, let's take a look at an example kind of similar to the one that's in your notes. Right, let's just go through these one at a time. So 1s is allowed. I think for this, we'll just say, we'll give an explanation if it's not allowed. 1d is not allowed, so N is equal to 1 only has S. 2s, that's allowed. 2p is also allowed. 3s is allowed. 15d is allowed. Anything with N is greater than is 4 or higher is allowed, or N is equal to 3 or higher is allowed for D. 3f, that is not allowed because N is equal to 3 can only have S, P, or D, but no F. And this is allowed. 5p is allowed. And then 2d is not allowed because N is equal to 2 can only have S or P. Now I'm just going to review what S, P, D, and F mean, and then we'll do another example. So these are just the examples from the notes. Right, so the S subshell is spherical. You don't need to label the axes like I've done here. It's just showing that it's three-dimensional. It can hold up to 2 electrons, so it can have 0, it can have 1, or it can have 2. And then if you don't have this in your notes, go ahead and add it. There is 1 orbital within the S subshell. So an orbital, that's just a mathematical function that describes the wave-like behavior of one electron. What that means is it's just an expression, a mathematical function that shows you where an electron is likely to be. Now we have the P subshell. I'm not going to expect for you to be able to draw it exactly like I have here. What I expect for you to know about the P subshell is that it is dumbbell shaped. There are 3 orbitals, hence why I've drawn it 3 different ways. And it can have up to 6 electrons, so 0, 1, 2, 3, 4, 5, or 6 electrons. It does not have to have all 6. It can have less, but it cannot have more than that. And we have the D. I don't expect for you to be able to draw all 5 of these, but I do expect for you to know that the D subshell is clover shaped. It has 5 orbitals and it can hold up to 10 electrons. So anywhere between 0 and 10 is allowed. And then we have the F subshell, which I'm not going to expect for you to be able to draw, but I do expect for you to know that it is double clover shaped. So just 2 clovers laid on top of one another. I recognize that the ones up top look a little bit different. We're not really going to get into that. There are 7 orbitals, and then it can have up to 14 electrons. Let's take a look through this problem. Okay, so 1F, before we actually do figure out how many electrons it can have, we need to figure out if it's allowed or not. Since this is not allowed, the answer is going to be 0. So 2s, that is allowed, and then because it is s, the answer is just 2 electrons. So a lot of students are often tempted to multiply it by 2 because they think it's multiplication, and I completely understand why students do that, but this is not a multiplication thing. When we say 2s, we mean n is equal to 2 in the s subshell. Okay, n is equal to 4, so we have here s, p, d, and f all are allowed. So 2 plus 8 plus 10 plus 14 is equal to 32 electrons are in n is equal to 4. 2p, so it is allowed, and then because it's p, the answer is just 6 electrons. N is equal to 2, I'm going to need to figure out what subshells there are. So that has s and p, which means 2 plus 6 is 8 electrons. Now for 3D, that is allowed, and then it's D, so 10 electrons. 4D, that is allowed, so again, just 10 electrons. And then N is equal to 1, that is just S, so therefore it is 2 electrons. I appreciate you taking the time to watch this video, and have a great night.